Okay, we're going to be looking at graphing piecewise functions, and we are going to be restricting our graphs to just piecewise linear functions. Your book does have some problems that deal with quadratics, but we're not going to be worried about that. The first thing I want to do is to highlight this first part of my equation yellow, and the second part I'm going to highlight pink, and I'm going to match those up with the graph. The yellow part of my equation with negative x plus 2 is for when x is less than 1, so that means it's to the left of 1. So it's this part of my graph. The pink part of my equation is for when x is greater than 1, so that is this part of my graph. Okay, we're going to think of this equation as really two different equations. Y equals negative x plus 2, and y equals 2x plus 1. When you're graphing a linear function, the two things that you're interested in are the slope and the y-intercept. And that's what I'm going to be interested in here as well. The other thing that I'm going to be interested in are my endpoints. Notice on this yellow part of the graph, this point down here at 1 is solid. It's colored in. I don't know if you can really see it that well, but it is a solid dot. So that means that this point 1, 1 is contained in this part of the graph. Up here at the point 1, 3, I have an open circle. So that point is not actually on that pink line, but I can get as close to that point as I want to. And the reason why is because I cannot have this 1 for my x value appearing twice. Remember that this is a function, so every time I have one input, I have one output. So I can't have 1, 1 and 1, 3 on my graph. It would not pass the vertical line test. In the equation of this yellow part up here, it says x is less than or equal to 1. So the 1 is going to be included on that yellow line. So pay special attention there to those endpoints. All of the problems that you're dealing with in my math lab are going to be multiple choice. So the first thing I want to do here is highlight my equations. The yellow part of my equation is when x is less than or equal to 2. So that would be to the left of 2. So it would be this line, this line, this line, or this line. Now what you need to notice about this equation is that its slope is negative 1. You can put a 1 right here if you want to. Slope is negative 1. Which of these graphs can I eliminate? Well, I can eliminate C. Now I'm also supposed to have a y-intercept of negative 1. So the b is negative 1. Remember, y equals mx plus b. So b is negative 1. Well, this graph has a y-intercept of negative 1. And so does this one. But this one has a y-intercept of negative 3. So that one I can leave out. Now, if you go back to your graph and you look at the graph of the pink part of 2x plus 1, my slope is 2. And both of these graphs that I have left are going to have slope of 2. Remember, slopes rise over run. And the y-intercept is negative 4. It's really not on my graph, but you can see that these two lines are the same. At first glance, choice A and choice B look exactly alike, but what's different are the endpoints. On this first graph, the point 2 is included right here, and on choice B, the point at the x value of 2 is included on this part of the graph. And there's an open circle here, there's an open circle here. So which one of these graphs is correct? Well, it all boils down to the endpoint on this particular problem. look at this inequality. The yellow part says x is less than or equal to 2. You're going to be on the yellow part of the graph. So when I'm at 2, I need to be on this yellow part of the graph. So I need to have B for my answer.